Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level puzzle, and it's called Balance by Skojo, who's actually he's definitely starting to become one of my favorite setters. Has a lot of very interesting variants on a lot of puzzles. And now onto today's rules. Normal Sudoku rules apply. Place the digits 1 through 9 once each in every row, column, and 3 by 3 box. Balance cells. Identify 9 balance cells in the grid such that there is one balance cell in every row, column, and 3 by 3 box. Each balance cell must contain a different digit. So there's 9 balance cells, one for each row, column, and 3 by 3 box, and each balance cell must contain a different digit. Remember that. There are no repeats in balance cells. The value of a balance cell is the arithmetic mean of the up to 4 digits orthogonally adjacent to itself, regardless of the digit in the balance cell. Okay, cool. So what does that mean? Arithmetic mean is basically means that you just sum up the values that are in the orthogonally adjacent cells, and then you divide by the number of cells there are. So for example, if this were a balanced cell, that would mean you would take the sum of, so orthogonally adjacent just means that they share an edge. So these are the orthogonally adjacent cells to this balanced cell if this were a balanced cell. So therefore, you would take the arithmetic mean, which means sum up these 3 digits and then divide by 3, because that's what the arithmetic mean is. And that is the value of that cell, would be basically summing up these 3 digits, dividing by 3, and then basically that would be the value of that cell. And you don't even care about what's in the cell itself. If it were obviously a different cell, say it was here, this would be that you would take the arithmetic mean of the 4 orthogonally adjacent cells. So therefore, you would sum up these cells and then divide by 4, which would be the value of this balance cell. And again, ignores the digit that's actually in the cell. So that's how balance cells works. Global balance. The sum of the values of every cell in the grid is 405. So therefore, okay. Normally, I think it is 405, right? 45 times 9, which would be 360 plus 45. Right? 45, 4 times 9 is 40 times 9 is 360. 5 times 9 is 45. Right. So then the values of every cell in the grid, if you sum them up, add up to 405, which is the normal value of a normal Sudoku grid, right? If you sum up all the values. But obviously with the balance cells, that can shift around how much each value is, right? So it's not necessarily the sum of 1 through 9. Okay, killer. The values of cells in a cage must sum to the total in the top left corner. Digits may not repeat within a cage, but values may. So basically, interesting. So in this cage, they add up. Okay, let's take one. Okay, so let's take this one. Shoot. Right. Okay. So in this cage, the values add up to 4. So the 3 values must add up to 4. And you cannot have repeat digits in the cage, but you can have repeat values. So obviously this would have to have repeat values somewhere, right? Because you can't have 3 digits adding up to 4 without, well, maybe you could. You actually could. It could be like 1.5, 1.5, and then 1. Well, that would be repeat values, though. Maybe you could have 1.5, 0.5, and 2. Okay, right. So you could have, you could actually have all three different values. But again, you can't have multiple repeat digits in the cages. So the digits may not repeat, but values can in these cages. And every cage adds up to a certain value. So these the values of these two cells add up to 9. The value of these two cells add up to 9. The value of these two cells add up to 15. The values of these two cells add up to 16, etc., etc. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so for one thing, we know if you have 3 regular numbers, they cannot add up to 5. So one of these 3 must have a balanced cell in it, which means the rest of the cells in box 1 cannot contain a balanced cell, right? Because you can't have 3 specific digits without 3 values of just digits adding up to 5, because you'd have to be like 1, 2, and 2. Therefore, one of these must be a balanced cell. What about these? This doesn't seem like it has anything specific. 54. Okay. You cannot have 9 digits just by the values adding up to 54, obviously. And in fact, I think you can't even have, you have to have 2 balanced cells, right? Because the highest balanced cell you can have would be 9. Let's say you had a balanced cell here, right? If you had a balanced cell here, the ones surrounding it could be 9 plus 8 plus 9 plus 8. So that would be 17. Well, actually, the highest value would be 9 and 8, 9 and 8. And so therefore that would be what? 30. That would be 17 times 2, which is 34, divided by 4. So the value would be 8.5. The highest balanced value you can get is 8.5. And if, let's say you round it down to 8, so as a value. Well, if you made the 1 essentially an 8 in value, that would give you the values 2, 3, 4, 5, 6, 7, 8, and 9, plus the 8. So 2 through 9 is 44, plus 8 is 52. And that by itself would not add up to the balance value of 54, or the cage value of 54. Therefore, this cage must have 2 balanced values. So one of them obviously is in box 4, but then one of them also has to be in box 7, because you can only have 1 balanced cell in each box, 3x3 box. So you can only have 1 in box 4, then you also have to have 1 in box 7, which means one of these 3 is the balanced cell. So the rest of the box cannot be a balanced cell. And the rest of the row, or column, cannot be in a balanced cell. Therefore, where is the balanced cell in box 1? It has to be one of these 2 cells, which eliminates all the rest of the column from being balanced cells. And this one cannot be a balanced cell. Therefore, this must be a balanced cell. We're going to make that one, which means eliminates all the balanced cells in the rest of the row. Okay. Now, this is a sum of 3 digits. Or this is, you would have to take the arithmetic mean of 3 digits. This could be 3 digits, or it could be 4. We're not sure. Okay, what about box 6? If you took the values naturally, So say there was no balanced cell in any of the cells here. You would have to have 2 digits adding up to 16, which could only be 7 or 9, and then 2 digits adding up to 15. But the problem is 2 digits adding up to 15 would have to be either 6, 9 or 7, 8, which is eliminated by the 7, 9 pair in box 6. So that cannot work. Therefore, in one of these 4 cells is the balanced cell, because otherwise it wouldn't work. So therefore, this cannot be the balanced cell. We know in the 4 there has to be a balanced cell because, again, the digits are unique. So if you didn't have a balanced cell in them, the minimum you would have to have in value of the cell would be 1 plus 2 plus 3, which would be 6, which is the minimum, and therefore that would not equal 4. So that doesn't, so one of these, at least one of these cells is a balanced cell. We're not sure which one. Hmm. One of these 2 is a balanced cell. What's the minimum a balanced cell can be? The minimum a balanced cell could be would be 1 and 2, and then 1 and 2. So that would be equal to 3 times 2, which is 6 divided by 4, which is 1.5. So the minimum a balanced cell can be is 1.5. Obviously, this contains only one balanced cell, so 1.5 is not allowed. So it has to be 1, 2, and 2. Because one of them, they're 2 whole digits. The balanced cell multiplication must be a whole digit, and it can't be 1, so it must be 2. Therefore, this is 1 or 2. There's a 1 or 2 elsewhere with it. We're not sure where. So this is 1 or 2, and this is 1 or 2 at least. This adds up to 18 without a 1 or 2, because we know, again, the 1 or 2 is one of these, and it must be with a balanced cell, which has a value of 2. Therefore, this has to be, again, without a 1 or 2. It adds up to 18. So it has to be 3, 4, 5, and 6. Because there's no 1, 2 possible. The minimum you could have for 4 digits is 3, 4, 5, and 6. 3 and 6 add up to 9, 4 and 5 add up to 9, so that's 9 times 2, which is 18. And this value is 18. So this must be 3, 4, 5, and 6. Which means the 7, 8, and 9 are in the rest of the box. Okay, so this is 1 or 2. We have 1 or 2 with 7, 8, or 9. So, say this was the balanced cell. What's the minimum of these 2 values? It would be 7 plus 3, which is 10 already. And then 10 divided by 4 is 2.5 at least, which is greater than what we need as 2. Therefore, this cannot be the balanced cell. This has to be a normal cell, which means this is the balanced cell. So this is 1 or 2, which means this is the balanced cell. Which means none of these can be the balanced cell in the rest of the row. And we know it has 3, so the rest of them must add up to 5, because you need the arithmetic mean to add up to 2. So 2 times 4 would be 8, so 8 minus 3 is 5. So this has to be 1, 2, 3, or 4 to add up to 5. We also know this specifically has to be 3 digits adding up to 8, and there's no balanced cell. So it's either 1, 2, 5, which is not possible because that eliminates all possibilities for that cell, or it's 1, 3, 4, which is possible. So therefore, this must be specifically 1, 3, and 4. This can't be 1 then, so that makes that a 2. This can't be 2, so this is 1. So this can't be 1. So these 2 digits add up to 5. So it's either 1, 4, or it's 2, 3. And so this can't be 3 because that would have to be 2 otherwise. This can't be 4 because that would have to be 1 otherwise. So this is 2 or 4. We have a 1, 3, 4 triplet here. Therefore, the 1 has to be one of these 3 cells. And this is 5, 6 with 7, 8, or 9. So 5 and 6 have to be here. We're not sure about any of these cells. Okay. Let's see. Right, so the minimum amount you can have for, again, the minimum amount you can have for a minimum value of a balanced cell is 1.5 because it's 1 plus 2 plus 1 plus 2 divided by 4. That's in the middle. On the edge, it's probably something else. It's 1 plus 2. It's 4/3 essentially, which is the minimum value if it's on an edge. And if it's in a corner, it's also 1.5, right? 1 and 2 divided by 2. So this has to be at minimum 1.5 plus 1.5 plus 1. So therefore, right, that's the exact value of a 4. So therefore, this has to be 1.5 plus 1 plus 1.5. So you need 2 balanced cells in this cage. Because otherwise it doesn't work. So therefore, this must be a balanced cell, which eliminates that as one of these two is a balanced cell. And if this was a balanced cell, that would mean there's only one balanced cell, which means that you have that minimum. Oh wait, no, you could have 2. You could have 2 with 1 and 1, right? Oh no, you can't have repeat digits. So again, if you had this as the balanced cell, that's that minimum 1.5. Say it was 2, right? Then you would have to have 2 values of 1, because neither of them could be balanced cells, but then you'd have a repeat within the cage. So this can never be the balanced cell, which means this is normal, which means both of these have to be balanced cells, and they have to have 1.5 in value, which means this is a 1, which would mean, again, the minimum is 1.5, and they both have to have 1.5, so this must be a 2, this must be a 2, this is 1 or 2, and this is 1 or 2. Obviously, this can't be 2, so that makes that a 1, which makes that a 2, which makes that a 1. Right, so then this would have a value of 1.5, which is 2 plus 2, 2 plus 1 times 2, which is 6 divided by 4, which is 1.5. And similarly here, this would be 1.5. So we know 1 can't be either of these, so therefore this must be a 1, because we don't have a 1 anymore in the rest of this box. So therefore this has to be 1. This is the balanced cell, so none of these can be the balanced cell, and none of the rest of the row can be a balanced cell. None of the rest of the column can be a balanced cell, nor this. None of the rest of this box and this row and this column can be a balanced cell. Okay, we don't know what this value is. These values don't have a balanced cell, so they must be specifically 3 and 6 and 4 and 5. Because 1 and 2 are no longer allowed. It can't be 1, 8 or 2, 7. So this is 3, 4, 5, 6. This is 1. This balanced cell must have a mean of 2, which means it's 2 times 4 for the surrounding cells. So therefore this must be a 4. And this cannot be 4 and 5 then. This has to be 3 and 6, which eliminates 3, 6 from the rest of the box. So therefore this is 4 and 5. We now have a 3. Okay, so then this also adds up to 18. And it does not have a 1 or 2. So by similar logic to box 1, box 9 must contain 3, 4, 5, and 6, which makes this 7, 8, or 9. We don't know what that is. Oh, this actually has to also be 7, 8, or 9 here. So now we have all the values of 7, 8, and 9 in a balanced cell. So none of the other balanced cells can contain 7, 8, or 9. Okay. This has to be 7, 8, or 9, and this has to be 7, 8, or 9. Okay, where are the 2s? This is two cells that add up to 14, and they uh, have to not be a balanced cell. So it's just the digits value themselves. So this is 5, 9, or it's 6, 8. Okay. Okay. So what we have here is we have a balanced cell here. What's the normal values of this? It would be 45, obviously. This is a normal value of 14 plus 8, which is 22. Oh. So the value of the cell is exactly the same as its normal value, right? Because it's 23 plus 14 plus 8 adds up to 45. Hmm. Interesting. I'm not sure if that tells us anything. This has to be a 4. None of these can be 2. In this cage, there has to be a 2 because there are 9 digits. And again, you can't have repeats within a cage. So therefore, you know there has to be a 2 here. But 2 cannot be here. 2 can't be here, obviously, because of this already. And this can't be 2. Whereas the 2, in this box, it has to be here. So this is 2. This can't be 1, and this can't be 1. This can't be 1, so 1 has to be one of the remaining digits. We also know we have 7, 8, and 9 here. 4 cannot be in any of these cells, so where is the 4 in column 2? It must be one of those. So therefore, this cannot be a 4, because we know in box 1, the 4 has to be one of these two cells. So then we have also 3, 5, and 6 in the rest of the column. This can't be 1. This specifically has to be the corresponding digit that's here, right? Because we have 6 digits here which are shared. 2 is not there. 4 is already taken into account. So this is the last digit that's here, right? Because it's not part of this 7, and therefore it's not part of this 7, and the 4 is already taken into account. So this has to be 3, 5, or 6. This can't be 3 or 6 because of the 3, 6, 3, 6 pair. The rest of the row has to be 1, 5, 7, or 8, or 9. This can't be 1, obviously. These can't be 1. Okay. So 2 cannot be the value in the balance cell in box 2 because we already have a 2. Neither can 7, 8, or 9. Therefore, this value has to be 5 or 6. Oh, that's interesting. This cannot... We have a 1, 4, 5 pair in column 4. So these can't be 4 or 5. Couldn't be a 4 anyways. The rest of this box must be 2, 7, and 5, 6, 8... 5, 6, 8, or 9. And this can't be 5 again. Okay, 2 is not in... Oh, these 3 must have a value. Okay, where is the possibility of 1 being... Well, 1 could be anywhere. Hmm. 2 cannot be here. This is again, it can be 2, 3. 6, 7, 8, 9, and obviously this can't be 2. Two can only go up how much? The max here would be 8 and 9, which is 17, plus 9, divided by 3. 17 plus 9 is 26, divided by 3 is 8 and 2/3. So then that would force this to be, if that's the case, to be 8 and 2/3. The 4 is one of these 3 cells. Let's see. Okay, so say this was the balanced cell. What's the most this could be? It would be 8 and 9, which is 17, plus 2, which is 19, divided by 4, which is 4.8 in value. But we know the value has to equal itself. So this cannot be the balanced cell then, right? Because if that were the case, again, this would be at most 1 plus 1 plus 8 plus 9, which is 19 divided by 4, which is, actually, no, it's 4.75. My apologies. It's 19/4. Yeah. 4.75, which is obviously not 5 or 6, which it would have to be here, right? Because it cannot be 2. 2 cannot be the balanced cell. What about the maximum here? I think that could be the balanced cell. What about here? These 3 cells. Again, the maximum of balanced cell. Okay, so the maximum of balanced cell could be if you had if it was here, it would be 6, 7, 8, and 9, which would be 30 divided by 4. So that would be 7.5. So this, if this were the balanced cell and it were the maximum, obviously that wouldn't really work very well. Well, we need at least a value of 6. This cannot be 1 or 2. The maximum value of a value here would again be 7. So then this would have to be 8 or 9 to compensate. And if this is not a balanced cell, then it would have to be 6, 7, 8, or 9. So that doesn't work. So this would be 6, 7, 8, or 9. This, if it were a balanced cell, again, could be 8 and 9 plus 7, which would be a value of 8. Which would, so this is a maximum value of 8, which means this has to be a value of 8 or 9, at least. But it still could be, without the balanced cell, 7, 8, or 9. Right. So we know the balance cell digit cannot be 7, 8, or 9 because we have 3 of those already. It can't be 2. So it's 1, 4, 1, 3, 4, 5, or 6. Okay, so if this were the balance cell, say this were the balance cell, we know then this has to be 7, 9, 7, 9. So this could be 9, and this could be, what would the values of this would be, right? It would have to be, this would be 7 and 9, which eliminates 7 and 9 from the rest of the box. So therefore, this would be 1, 5, and 8, but this couldn't be 1. This couldn't be 7, 8, or 9 because of the 7, 9 here and the 1, 5, 8 triplet in box 6. Therefore, this would have to be 6, which means this value of this balance cell would have to be 9, which is impossible, right? Because the maximum which we showed was 7.5. Therefore, that cannot be the balance cell. And therefore, this is the balance cell, which means this cannot... Oops. This is the balance cell, which means this is not the balance cell, which means this has to be the balance cell. Which means neither of these can be the balance cell. One of these two is. This has to be a whole number. It cannot be a fraction. And it must equal at least 7. So it must be 7 or 8. Which means these three add up to 21, or they add up to 24. So 1 can never be here. This is also 6, 7, 8, or 9. And this is 7, 8, or 9. Aha. We have a 1, 5, 6, 7, 8, 9 quadruple, or not quadruple, sextuplet. Sextuplet in box 6. That means 1, 5, 6, 7, 8, 9 cannot be in the rest of the box. So this has to be 3 and 4 and 3 and 4. Now we have a 3, 4, 3, 4 pair in row 5. So the rest of the row cannot contain 3, 4. So therefore this can't be 4, so this is 5. This can't be 5, so this is a 4. This can't be 3, 4, or 5, so it has to be a 6 then here. Which means the rest of this cage cannot contain a 6. So therefore, this must be specifically 3 and 6. And we have 4 and 6. Which means we cannot have a 4 or 6 in the rest of the box. So therefore, this must be 3 and 5. So this is a 3 or 4. This is 6, 7, 8, 9. This, therefore, where is the 6 in box? Box 6. It can only be here, which means this is 6 and 9 added up together. So this can't be 6, so therefore this is 9, this is 6. This can't be 9, this can't be 9. None of these can be 9. Where's the 1 in box 6? It has to be here. So this is a 1, which means neither of these could be 1. So therefore, this is a 1. This can no longer be a 1. This can no longer be a 1. This has to, again, add up to 21. Or 24. If it's 21, it would have to add up with 9 to form 16. But it can't be. There's no 9 possible now because this has to be 6, 9. So this can't be 6 or 9. And this can't be 6. Actually, that tells us a lot. Where is the 6 in box 9? It must be one of these two cells. Therefore, that eliminates 6 in the rest of the column. So this can't be 6. Where's the 6 now in row 3? It has to be here. So this is a 6. Again, this can't be 7. Sorry, this can't add up to 21, because if this adds up to 21, that means it's 21 divided, the mean is 21 divided by 3, which is 7. So this would have to be 7 value plus 9, which is not possible, or because the 9 is already there. So therefore, this can't be 21. It must add up to 24 to be divided by 3, which would make 8. So therefore, this is 7, 8, and 9. And we have a value of 8, which means it must be with 8. So this is 8, and therefore this is 7. We now have a 7 and 8, which means this can't be 7 or 8, so this must be a 9. This can't be 7, 8, or 9, so this is 5, so this can't be 5. Cannot be 5. This can't be 5 because of this 5, therefore this has to be 5. Now we have a 3, 4, 6 triplet in column 9. So the rest of the column cannot contain 3, 4, 6. Therefore, this must be 2. Which means neither of these are 2. Which means one of these two has to be a 2. Let's see. This, whatever the balance cell is here, it cannot be 5 or 6. And it cannot be 7, 8, 9. It can't be 1, and it can't be 2. So this one must be a 3, 4 balance cell, which means 3 and 4 cannot be a balance cell in any of the rest of the cells. Well, we also know we need a balance cell that contains a 1, because all the balance cells contain 1 of each digit, because there are no repeats. So where could you possibly have a balance cell that has a digit of 1? It cannot be here. Cannot be in any of the ones with a 1 that's not a balance cell. So it must be here. So this must be the balance cell, and it must be 1. Therefore, this cannot be a balance cell. These can't be balance cells. One of these two is. And we know 5 or 6 is here. We also know 5 or 6 is the balance cell here. We're not sure which, though. One of these is 3 or 4. One of these is 3 or 4. Oh, this can't be 7 or 8, so this must be 5. This can't be 7. This can't be 5 or 7, so this is 8 or 9, and this is 8 or 9. This can no longer be 1. Where is the 1 in box 4? Can't be here, can't be here, can't be here, can't be here. It must be here. So this is 1. This can't be 3 or 5 or 9. This can't be 9 because of this 9. This can't be 9, and this can't be 9. So we have a 7, 8, 7, 8 pair here. Therefore, this must be 9, and it must have a 3 or 4 with it. Okay, this has to be 7 or 8 with 3 or 4. Right, because it cannot be 5 because we know the 5 is here, and then we cannot be 1, 2, 6, or 9. So this is 3, 4, 7, or 8. Okay. This cannot be 3 or 5. Where are the 3 and 5 in box 4? It can't be this because of the 3, 5, 3, 5 pair up here. It cannot be here because we've eliminated both 3 and 5 from the rest of the rows. So this can't be 3 or 5. Therefore, this must be a 3, 5 here. So this is 3 or 5, this is 3 or 5. This can't be 8. So this has to be 7 or 9 because we have the 3, 5, 3, 5 pair here. One of these is 3 or 5, and one of these is 7, 8, or 9. Where's the 2? The 2 has to be one of these two here. This can't be 9 anymore. Let's see. Can this ever be 9? No. Because if this were 9, that would mean this value would have to be 1. And again, you can never have 1 as the value, especially if this is 9, right? So then this would be 10 at least, which would make this 13 at least. 13 divided by 3 is 4 and 1/3. So you would have to have a value. You would have a value of 9 plus minimum 4 and 1/3, which is 13 and 1/3, which is already greater than that. So this cannot be 9, which means where is the 9? It has to be here in column 7. So therefore, none of these can be 9. Therefore, the 9 is one of these 3. Which means this can't be 9 here. So 9 has to be one of these two. This is 3 or 4. So this can this value ever be 6 is part of the question. And can it be 7 also? So this is divisible by 3. And this is, or what is divided by 3. So it could be 2/3 and 1/3 in value. Also, can this ever be specifically 6 in value or 7 in value? If it's 6 in value, that would mean these 3 must add up to 6 times 3, which is 18. But the problem is, if this is 6 in value, this would have to be with a 4. And that would be 5. Therefore, to add up to 18, this would have to be 13, which is not a digit. So that's not possible. And what if it's 7 in value? Obviously, it's the same problem, right? This would be 7. This would have to be 3. This would be 7 in value, which would make this a 3. Therefore, it'd be 1 plus 3, 4, to add up to 21, because that's 7 times 3, which is 17. So that doesn't work either. So this cannot be a balanced cell. Therefore, this is the balanced cell, and it has to be 3. Therefore, these must add naturally to 10, which makes this 3, that's 7, which makes that 8, therefore this is 4. So therefore, this can't be 3. This has to be 4 then, which makes that a 3. And this can no longer be, this has to be 4 and 6, which makes this 3 and 5. Okay. So 7 can no longer be here. This can't be 7, therefore this makes that 8. This cannot be the, whatchamacallit, the, balance cell. This can't be 8. And we know the balance cell, we know there's a 2 here because of the way that this works, because this can't be 2, this can't be 2, and the 2 cannot be here. So one of these is a 2. The other one is a balance cell, because we know there's a balance cell there. And the balance cell cannot be 7, 8, or 9. So it must be 5 or 6. Therefore, 9 cannot be here, which means this must be a 9, because it's the only other place for the 9 now in box 2. So therefore, this is a 9, which forces this to be a 5. So this can no longer be 5. This can't be 5. This is now a 3. This can't be 4, so this is 6. So this cannot be 6. This has to be 7, 8, and this has to be 2 and 6. This can't be 6 because of that 6, so this is a 4. This can't be 3, so this is a 5. So this is a 6, right? That works. This is 2 or 6. One of these is a balance cell. We're not sure which. But it has to equal 6 times 3, which is 18. Right? Because it has to be the exact same value, because it's 23 plus 14 plus 8 is 45, which is what they would naturally add up to. So the 6 must add up to, if this were 6, it would be with 2 and 8, therefore this would have to be 8, if this were the balanced cell. If this is 6, that would be 2 and 9. So, okay, again, if this is the balanced cell, this would be 6, this would be 2. Therefore, and they have to add up to 18 to make it exactly the same. So this would be 8 and this would be 7. If this were the balanced cell, this would be 6, this would be 2. These two add up to 11, but these three must add up to 18 also. So therefore, that's 7 and that's 8. Either way, this has to be 7 here and 8 here, wherever the balanced cell is. So therefore, this is 8 and this is 7, which means this can't be 8. This must be 9, which means this can't be 9. So this is 7. This can't be 7 because of the cage and the balanced cells contain only no repeats. So therefore, this is 8. This can't be 7 or 8, so this must be 9, which makes that 7. This can't be 7. Therefore, this must be 9, which makes that 8, which makes that 7, which makes that 8. This can no longer be 8 or 9. This can't be 8 or 9, and it can't be 7 here. Now we have a 3, 5, 3, 5 pair in column 2, so the rest of the column cannot be 3 or 5, and this can't be 8. Therefore, this is a 9. We know now this has to be 16 divided by 3 for the value. So what is that? 1 plus 8 plus 7 is 16 divided by 3, so it's 5 and 1/3. So that goes from 2 to 5 and 1/3. So this is 5 and 1/3. We have 3 through 9, so that's 42, right? 3 through 9 is 42. This has to be, what's the remaining cells here? 4, 6, and 8. And the remaining cells here are 2, 3, 5, and 7. And this can't be 2. This can't be 8. Okay. One of these is 8. We're not sure. This cannot be 8, so this is 7. None of these can be 7 then. Again, this is 5 and 1/3 plus 42. Because this is 3 through 9 added up, which is 45 minus 1 minus 2, which is 42. 42 plus 5 and 1/3 is 47 and 1/3. 54 minus 47 is 7, minus 1/3 is 6 and 2/3. Therefore, these three digits must add up to 20. Okay. Right, so let me just double check. This is 42. 54 minus 42 is 12. 12 minus 5 and 1/3 is 6 and 2/3. 6 and 2/3 times 3 is 20. Right, because it's 20/3 and then multiplied by 3 is 20. So this cannot be 2. So this has to be a 2, which means this can't be 2. So the 2 is one of these two here. And it's either 3, 8, and 9 or 5, 6, and 9, adding up to 20. We have a 3, 5, 3, 5 pair in row 9, so the rest of the row cannot contain 3 or 5. We have a 2, 6, 2, 6 pair in column 4, so the rest of the column cannot contain 2 or 6. So this is 3 or 7, this is 3 or 7. We have a 3, 5, 7 triplet in row 7, so the rest of the row cannot contain 3, 5, or 7, so this is 4 or 6. The rest of this is 3, 4, 6, or 8. We have a 3, 7, 3, 7 pair in box 8, so this cannot contain a 3. This is now a 4, 6, 8 triplet. We have a 4, 6, 8 triplet in box 8. So therefore, the rest of the box cannot contain 4, 6, or 8. So this cannot contain a 6, so this must be 2, which makes this a 6, which makes this a 2. Therefore, this is the balanced cell. This is not. Therefore, this can't be the balanced cell. Therefore, this is. And we know this contains a 5 because that's the only digit that's not in a balanced cell. So this is a 5. This has to be a 9 specifically. Okay. Now we have to add up the values. This is 9. Okay. So this is the same. So that's good. So therefore, that's 0 in value. This... Ooh. What does this do? This is 26 divided by 4. Oh my god. Ugh. 26 divided by 4. So this is still 6 in value. So this is 0, net 0 here. This is a 2 in value. So it's minus 7. So we've lost 7 in value so far. So it's minus 7. This is 26 divided by 4, which is 6.5, which is a gain in 2.5 in value. So it's minus 7 plus 2.5. So that's minus 4.5. This is 24 divided by 3, so it's 8. So this is like plus 5 in value. So now it's plus 0.5 in value. This is 15 combined minus 3, or subtracting 3. Okay, maybe that's better to go this way. So again, okay. This is 9 down to 2, which is negative 7. This is 6 stays the same, so this is still negative 7 here. These two combined, this is 20. This is 1 and 2, so it's 3 in value going up to 12. So that's a difference of 9 between adding these and subtracting out this. So it's 12, 3 to 9, sorry, 3 to 12, which is plus 9. This is 9 to 2, which is minus 7. So plus 9 minus 7 is 2. So we have 2 in value here. This stays the same, so that's fine. This goes from 3 to 8, which is plus 5 in value. So that's 2 plus 5 would be 7. This is 15 going down to 3 in value, which is minus 12. So therefore, this is, it's plus 7 minus 12. So this minus 5 right now in value. This, so it's minus 5 in value. This is minus, this is plus 2.5 again. So now we have to have another plus 2.5 in value. So this is value of this must be 7.5, which is exactly 6, 7, 8, 9 divided by 4. And 6, 7, 8, 9 is the max you can have around a central cell. So this must be 6, 7, 8, and 9, which makes this a 3. This can't be 6 or 8, so this is 4, which makes this 6, which makes that 4. This can no longer be 6, so this is 8. Therefore, this must be 3, 8, and 9 to add up to 20. So this is 3, this is 5, this is 3. This can't be 3 or 5. This has to be a 5, which makes that 3, which makes that 5. This has to be 7. This can't be 6, so this is 4. This has to be a 6, and now we're just doing Sudoku. This is 3, this is 6, this is 3, and that's a 4. Very cool puzzle, actually. Very cool. It wasn't that hard. You just, probably the hardest part was the maths. Yeah, very nice puzzle. I like the new balance set rule. Yeah, and anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.